Hey, this is Mr. Ward. Now I'm going to do a short video on graphing standard form linear equations. So standard form is some number times x plus some number times y equals some number. In standard form, formally, this number, which we often call uppercase A, is supposed to be a whole number, a positive whole number, and all this number, which is called a coefficient, the coefficient of x, the coefficient of y, and the coefficient that is constant out here, the a, b, and c, uppercase A, B, and C, are all supposed to be at least integers. You don't have to play it that way, but that's the formal rule. It would be mathematically fine for them to be fractions and stuff, and the lead coefficient here, the x coefficient, to be negative. But here we have the basic structure. It's the product of some number in x and the product of some number in y added together gets us a number. So with this form, we aren't handed a slope or handed a point. We have to do a little bit of work to get points. And the way we do this is we start off by just getting the intercepts. So to get the x-intercept, I turn y into 0. So 8x plus 11 times 0 equals 88. And I solve for x. I don't even care about 11 times 0. So I'm just going to have 8x equals 88, and so x will be 11. So I'm going to have an x-intercept, which will be at 11, 0. Fix that. That should be a comma. And now I'm going to find the y-intercept, which will be at 0, something. Now, since that's going to be at 0, something, I'm going to take this equation and I'm going to replace x with 0. So x will be 0. So it's 8 times 0 equals 11y. Or sorry, 8 times 0 plus 11y equals 88. So I don't care about 8 times 0. So really, it's just the y-intercept is coming from 11y equals 88. And so y is going to have to be 8, because 88 divided by 11 will be 8, so the y-intercept will be at 0, 8. And now I can plot my points and then draw my line. So 11, 0, let's move this x-intercept over to 11, 0. And I'll move this y-intercept up to 0, 8. And then I move my line so it goes through them. So there, and a little bit above it so I can move it down. And there, I've got my line. I could, of course, if I want, stretch that out a little bit, line it up just a little bit more. And I have plotted my line. It's not perfect, but it is good enough for the purposes of this exercise. So plot 2 points, get a straight edge, draw a line through them. That's the procedure for graphing any linear equation. Now, the next one, they make it a little more complicated because one of our intercepts is not going to be a neat and tidy point. So let's work out what our intercepts are. So to find the x-intercept, I ignore the y term, and I just do 5x equals 36. So 5x equals 36, and I solve for x. X will be 36 over 5, which is 7.2. Okay. Now, that's not going to be so easy to graph. 7.2 is somewhere between 8 and 7, so a little closer to 7. But we can, so we've got an x-intercept. We'll plot that, which is going to be at 7.2, 0. We can plot that if we want to, but I'm probably not going to plot that one. But let's see if the y-intercept is any easier. To get the y-intercept, we ignore the x component because x will be 0. And go ahead and solve for just y. Because x became 0, all we care about is negative 6y equals 36. And yes, that is a negative, minus 6y we preserve that negative. Okay, so let's solve this. We're going to do both sides divided by -6. So y ends up being -6. So now I have a y-intercept I could plot. That's a little easier to plot, 0, -6. So let's go ahead and plot the one that's easy to plot. 0, -6. I don't know, earlier I was pointing up here for the 7.2. It should have been over here because it's an x-intercept. Some of you might have noticed that. It's like, there needs to be a comma. Okay, so there is my y-intercept. Now, how am I going to get another point? This point is not neat and tidy. What I want to do is I want to find the slope. Well, the slope in a standard form is the opposite of the x coefficient divided by the y coefficient. It is -a over, let me do that again, -a over b from the ax plus by equals c structure. So I talked to you all a little bit about that earlier, but you can work out how the slope works from the intercepts, because it is the intercepts. Oops, I didn't mean for all those sliders to show up. Okay, so the intercepts are going to be at c over a, 0, and 0, c over b, because to get the x-intercept, we simply divide the c coefficient by the a coefficient. To get the y-intercept, we divide the c coefficient by the b coefficient. Then to get the slope, it's going to be the change in y over the change in x. So the change of y from 0 to c over b, or we could go this way, c over b to 0 would be, oh, sorry about that. Okay, I'm going to have to do it above it, or else it's going to demand sliders. So I go here. Change of y is going to be, I'll go 0 minus c over b. And that's going to be over change of x, which would be c over a minus 0. And we can simplify that nicely to -c over b over c over a. And that, if you remember, fraction bars are division. So -c over b over c over a means we'll keep change flips. So we can rearrange that from division, multiplication. Instead of divided by c over a, it's times a over c. And the c's will cancel out. It's negative, so this will end up being a 1. This ends up being a 1. And now we've just got a over b, but negative. So that's a, and our slope ends up being -a over b, and that's where that comes from. So get rid of all of this stuff. So slope is -a over b. And since we have an a and we have a b, we can just replace those. So a is 5 and b is -6. And we got -5 over -6, and that's very convenient. That means we're going to go up 5. So 1, 2, 3, 4, 5, and then over 6. So this point, okay, I'm going to move it down here so you can see that happening. So we're going to be from here up 5 from -6. So up 5 from -6 brings us up to -1 for y. And then over 6 brings us over to 6 for x. So we're at 6, -1. And that is another point that we've got. I could also do it mathematically. I could say the x component is going to be 0 plus 6, and the y component will be -6 plus 5, because vertical change in 5 over 6 is 5, horizontal change is 6. That becomes 6. Negative 6 plus 5 becomes negative 1, and that's exactly where we are. So I'll drag this around and maneuver it where it needs to be. I'll line it up and move it over, and there. Oops, I think I adjusted more than I meant to do, so let me adjust back. So this is all I think I ended up actually moving the whole graph. Just want to move this. There we go. So that's there at negative 6, a y-intercept of negative 6. And this is not our x-intercept, but you can see it does make the line go through 7.2-ish on the x-axis. So in the case where one of the intercepts is not neat and tidy, you want to plot whichever one is neat and tidy. Hopefully there is one. If there's not, you can eyeball things like 7.2 on a graph. But then you can use the slope to map another point. So the slope again is negative a over b, okay, for the standard form. I'll just write that in here, remind you one more time. You should probably write that down. The slope for standard form is negative a over b, and the standard form is ax plus by equals c. All right, I'm going to stop, and I hope that helped.